Good afternoon, ladies and gentlemen. It's my great honor to present EnvironRem and to discuss our China case studies. My name is Philip Luo, and Chinese name is Luo Chunhui. So here, a very brief introduction about the EnvironRem. EnvironRem is a very young but fast-growing company. It was established in the year 2011. And we are targeting for the environmental solutions, and also we are targeting for the contaminated land redevelopment and green and sustainability development. EnvironRem is a China government-funded company. It's a professional environmental remediation company. We headquartered in Zhejiang province, and we now have 5 offices. Including Guangzhou, the Pearl River Delta area. So we are trying to find a real collaboration with foreign technical companies, and also we have a lot of existing projects. So we want to share with everyone and to see if we can find a real collaboration in the future. Here's the services we offer. We focus on the environmental remediation, as I mentioned. And we also we gonna do property redevelopment, design new construction, energy solutions, and sustainability solutions in the future. Because we believe environmental remediation in China is like a very comprehensive problem. So we need to find different sources and to combine them. The way we find the remediation solutions here, basically there are 4 key factors we consider. First is the political feasibility and the technical feasibility. And we also will discuss the project schedule with the government or with the client. But most importantly, I believe in China now is the funding mechanism. Because the funding right now is a very complicated issue, either from the government funding, from the client's funding, or for some third-party funding, like land developers. It's not clear in China. So for every company, like our China local company or foreign company, I think we must have a very good understanding for this before we can do any success project here in China. The remediation solutions, here's a very brief conceptual model. First, we have to learn and study the pollution media. There's various media like gas, soil sediment, groundwater, and surface water. And we have to understand the contaminants, its transport pathway, its motion pathway, its transport model, and risk assessment involved. In that case, we can identify the best available treatment methods. Like we already know, there are many different types of treatment technologies available. We have in-situ, ex-situ treatment technology. We also have on-site, off-site options. There's many other like physicochemical, biological separation, or thermal destruction, and even the contaminants methods. We already find some projects here in China using these different kinds of technologies. And we will see more emerging technology will be being used in China in the next 2 years. The key factors for the technology selection, especially in China practice, we also have to consider the current and future land use. And we also have to understand the exposure pathways. That's why China EPB and also the government, they introduced the risk assessment tools for the China remediation, like determine the treatment goal for each project site. And we also need to have a good project management. This project management is combined with the government project management and with the client project management as well. But in China, the government, especially the political issues, is quite complicated. So we have to understand the schedule and the financing status of the local governments. In that case, our project management is even complicated. So that's, I think most of us already find this doing challenging issues here in China. Second part, I will briefly introduce our in-situ chemical oxidation technology. Actually, it's widely used in Netherlands. In-situ chemical oxidation, actually the oxidants used to destroy the contaminants in soil and groundwater. From the right picture here, we can see it's a very simple conceptual model. The oxidant was injected via the injection well and circulated through the extraction well. So we already find the chemical oxidation projects here in China, mostly for the organic pollutant side. Let's review the oxidants in the soil and groundwater remediation. Look back in the 1980s, hydrogen peroxide, or we know as phantom, or namely CHP reagents, was first introduced for the soil and groundwater remediation projects. And starting in the 1990s, we find ozone and permanganate was used in loss of remediation projects. And starting in the year 2002, we find some cases for the persulfate. Actually, this is activated persulfate used in the real remediation projects. And later on, we find the solid peroxide, like the calcium peroxide, magnesium peroxide, and even the carbon peroxide was largely used in some remediation project sites. Starting in the late 2007, I think a lot of remediation sites also started using the surfactants to enhance the remediation. So the in-situ chemical oxidation, namely ISCO, can be used to treat a lot of chemicals like BTEX, BTEX, MTBE, TPH, and chlorinated solvents, PAH, PCBs, CBs, and pesticides, and also the explosive compounds. So we find it's a very useful remediation technology, and also very suitable for some remediation site in China. Here's a very typical in-situ chemical oxidation project site. We'll see the injection well here, and oxidants through the injection. So you will find a more common practice here in China, as this project site is in Jiangsu province and Zhejiang province, and even more in the Pearl River Delta area. In-situ oxidation is also widely used. Here we'll see the polluted soil was first excavated, and all the oxidants are injected through the piping system. Pros and cons for the ISCO technology. First, the cons. ISCO technology is very fast and a short-term treatment technology. It can be finished the contaminated site maybe in months. And it can be used in situ, and it's very suitable for most organic pollutant soil and groundwater contaminated site. And the end products usually is environmental friendly, so it can be accepted by a lot of Chinese legislations. Some disadvantages also, because oxidants here, like what we reviewed first, mostly is non-selective oxidants. So it needs actual oxidants to destroy the contaminants or the organic pollutants in the natural soil. And it also, usually we're going to find the concentration rebound, which means the concentration is going to be increased even during the remediation work. And the remediation work will also release a lot of heat. So that's a lot of safety issue we need to be aware of. The last part, I want to very briefly review one of our case studies in Shanghai plant. I'm not supposed to disclose the client's name, but the main pollutants is BTEX and TPH, is for the vitamin oil production facility. The biggest challenges for that site is still in operation, and the chemical injection was in the anti-explosion zone. So for our environment solutions, we designed a very simple free product recovery system. And we use the air-driven diaphragm pump for all the system design. Totally 3 rounds of chemical injection are conducted, and we are targeting to reduce the mass removal of the BTEX in the groundwater greater than 80%. Here's a site investigation and delineation. We can see here from the groundwater monitoring data, taurine and BTEX is the most contaminant pollutant here. And the polluted source here is in the vitamin oil production building, right here, outside the vitamin oil production building. And we find the BTEX and TPH heavily polluted site here. Here's a very quick compare between the taurine concentration, the contour map, and the soil gas contour map. Along the groundwater flow direction here, we'll see the soil gas actually a little bit of migration from the source zone. But overall, the groundwater contamination and the soil gas contour map still in a good match. Here's the in-situ chemical injection system. From this right-hand side picture, we can see we use 4 different types of the piping system, including the water, sulfuric acid, hydrogen peroxide, and the compressed air. Actually, the compressed air is supplied by the factory, and it serves 2 purposes here. First thing, it can be used for the air-driven pump, the diaphragm pump, because it's anti-explosion zone. And second, we use the compressed air to help the in-situ chemical oxidation, because the radio of influence, the ROI of the injection well, can be expanded by using the compressed air here. So that's a very smart design for this kind of remediation system. So this is the pictures. We see comparison between the taurine concentration for the baseline before the injection and after the first round injection and second round injection. I skipped the third round injection and the follow-up monitoring data. But here you can see after the first round injection, the plume is expanded, and the concentration actually will find a certain spot is actually rebound, a very obvious rebound. But after second time injection, we will see the pollution zone is shortened, and which means the chemical oxidation is taking effect. And the follow-up injection and monitoring data convinced that. So totally we inject like 15,000 liters of sulfuric acid and almost 40,000 liters of hydrogen peroxide. So a lot of work has been done for this small area of the polluted leaking site. The area I forgot to mention is only about 2,000 square meters. But the leaking, the deepest BGS contamination is about 9 meters below ground level. So very small project as new and full-scale implementation in short term using ESCO. So basically, I think that's a really good case example for us to learn from it. And maybe for the future, we can find more large ESCO projects here in Guangdong, in the Pearl River Delta area. And finally, this is our website. You can find more information for the EnvironRem. We are ready to collaborate and open to questions. Thank you.